In this video, I'm going to show you a couple examples of how to sketch a hyperbola by hand. Hopefully you've seen a hyperbola. Maybe your math teacher's already tried to show you how to do it. I'm going to do it here on a couple of examples just to show you the basics so that we can find the important information out of a hyperbola. First off, it might help to know what a hyperbola is. So I have the same image here that we had earlier. And what I have, I went ahead and cleared it. I'm going to move the graphics view so you can see. And what I have here is a point on the outside of a circle, a point on the circle, and the center of the circle. And then this line here, this pink line, is a perpendicular bisector between the point on the circle and the point outside the circle. Then this point E here is along a line that goes from A through the point on the circle, and it's always on this perpendicular bisector somewhere, but it always follows this line. And I turn the trace on both of these so you can see it trace out a hyperbola. You can do the same with wax paper. So if you take wax paper and make the same folds between the point on the circle and the point outside the circle, the folds will create this nice hyperbola that you see here. So if you notice, we have this hyperbola, we have the point here and the point A here, which those are the foci of the hyperbola, and all of these tangent lines are in the middle. And so what's kind of neat is, well, we'll go ahead and move this. So if you move that point out a little further away, it changes the eccentricity of the hyperbola. So let me clear things out. And we'll go ahead and rotate this again. Still, same thing. This is a perpendicular bisector. Okay, so without further ado, I'll go ahead and make the hyperbola. And you can see that it's a very wide hyperbola that's created as I rotate that point around. So that's kind of a fun way to create hyperbolas. But let's look at the algebra. So we'll go through all the vocab, and then we'll talk about what or how to find each of those things in the vocab. So this is just the general form of the equation here, but you need to realize that the only difference between this formula and an ellipse is the minus sign. And so you could have the minus sign going with the y, or you could have the minus sign going with the x. And we'll address both of those situations in this video. So the first thing is, I'm just going to show you, go through everything. We're going to have a center, which will be HK, like it normally is. We're going to have a transverse axis, a conjugate axis, vertices, just like on an ellipse. What's different is we're going to have asymptotes, and I'll show you how to find the foci. So without further ado, I think the best way to learn this is just learn by doing and looking at an example. If you've already graphed these before and you're just doing this as practice, go ahead and give it a shot. Hit pause, see if you remember how to rough sketch this thing out. So what I would do first in this case is find our center, which our center is 3, -2. So I'll graph that. And so if you go right 3, 1, 2, 3, and down 2, that's the center of our hyperbola. And what we're trying to do here is create a scaffolding for the asymptotes. So everything, the transverse axis, the conjugate axis, is going to do that. So the first thing is you find the distance to our vertices on our hyperbola, and you use 4, so you take the square root of 4, and so which is 2. So we're going to go right 2 and make a point, and left 2 and make a point. And so that's this line along there, and I'll do it in black. This line is called the transverse axis. Okay, not really real important, but those vertices are. And then you do the same in the y direction. Since 16 is underneath y, we're going to go up 4 and down 4, because the square root of 16 is 4. So 1, 2, 3, 4. 1, 2, 3, 4. Kind of off my grid just a little bit. But the key here is this is where you draw an ellipse, and you'd have a rough sketch of an ellipse. This is not an ellipse. What this is instead is the scaffolding for our asymptotes. So I'm going to draw a box. Didn't do real wonderful there. And then I'm going to connect the diagonals of my rectangle. And I'll show you the whole thing when I'm done here. And these are my asymptotes. So we're going to find the equation of both of these. If you're not sure what an asymptote is, take a look at it. Lots of great videos on what an asymptote is. And what this tells us, and since the x is positive right here, since x was positive, y was negative, I know my hyperbola is going to start at this vertex point and follow along in this general manner. I'm not here to give you the exact values. We could plug those in anywhere. We just want to get a rough sketch of what this thing looks like. And so this green line will never, it'll get closer and closer to the asymptote, the blue dotted line, but it'll never reach it. And so these green lines, that's actually my hyperbola. The next thing is we need to find the focus. And sorry, I did leave out the conjugate axis. That conjugate axis was in this direction here. So that's the conjugate axis, the one away from the hyperbola, or perpendicular to the hyperbola, or the transverse axis. So some things to do now is we need to find the focus, we need to find the foci, there's 2 of them. We need to find the equation of the asymptotes. And so let's find the focus first. So to find the foci, the distance to the focus from the center is almost the same as ellipse, but instead of subtracting a squared and b squared, we're going to add a squared and b squared. And so we know a squared and b squared are 4 and 16. So we would have c squared equals 4 plus 16. And so c squared equals 20. So c is equal to the square root of 20. And the square root of 20, that's about 4.5. You could find that if you wanted to. And again, I only do that so that we can get the rough sketch of it. So if you go right, 4.5, so 1, 2, and about 4.5, about right there. There's one foci, and then left 4.5. So about right there. There's approximately where our 2 foci will lie along the transverse axis. Then the last thing you usually need to find with asymptotes is the equation of the asymptotes. And I would use the general form. Now you could use y equals mx plus b because they're aligned, but what's nice is you have this center point that's in both lines. So I'm going to use the point slope form of a linear equation, which is y minus y1 equals m times x minus x1. And so we know our slope is, if you count from our point, it's rise, so let's say for this one here, so it's rise 1, 2, 3, 4, run 2. So this slope is 4 over 2, which reduces to 2. And this slope here is 4 over negative 2, which is negative 2. So we can find that equation really quickly by plugging in our point. This point is our center. We have that. That's 3 comma negative 2. So we're going to plug in 3 negative 2 and our two slopes, which are plus or minus 2. So our equation of our asymptotes, and you can combine it into one sentence here, but it'd be y plus 2, because it's a negative 2, equals our slopes, which are either plus or minus 2, and then x minus 3. And you could distribute that and find the point slope form, or the slope intercept form of the equation, but for now that's going to be good enough. So it's y plus 2 equals plus or minus 2 times the quantity x minus 3. So those are your equations of your asymptotes. So go ahead and give it a try on this equation, and I'll go through this much quicker. So hit pause, try it, and here we go. So the first thing is, I was kind of mean to you. Notice y leads. There's nothing under it, so we're going to put a 1 there. And that's where I always start. So my center, you have to be really careful because your x is on the right side this time. So my center is negative 2, 3. So I'm going to go right 2, down 3. Oops. I just need to extend it. Sorry. Right 2, down 3. Right there's my center. And my transverse axis is the square root of 1 this time. And I'm going to go up and down. So I'm going to go up 1, down 1. That's my transverse axis. I'm not going to draw a line through it this time. And I'm going to go right and left 5 because it's underneath x. So right and left 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And instead of an ellipse, we're going to draw a rectangle, which is the scaffolding for our asymptotes. So we're going to connect our diagonals that go through the center, and there's our asymptotes for our hyperbola, which we'll find the equations of those lines. Didn't do so hot drawing that in, but not bad. Like I say, these are just rough sketches. If you want something precise, you can use a computer for it. Then your y leads. So this tells me that my hyperbola is going to open up and down. Here's my vertex for the top one. And then the bottom, same thing. Here's my vertex. Again, that dotted line should go through that box, or through that point. And so there's my hyperbola. We need our foci, which you take c squared equals 25 plus 1. So c squared equals 26. C is equal to the square root of 26, which is about 5.1-ish. If you do, you know the square root of 25. So I'm going to go from my center up 5.1. So 1, 2, 3, 4, 5.1 would be, there's one of my foci. The other one is going to be 5.1 down. So 1, 2, 3, 4, 5, and then a little bit further. So there's my other foci. I kind of ran off my graph a little bit. If you could imagine it extending down, that's approximately where they're at. Then the last thing to find is the equations of your asymptotes. So we're going to find the equation of this one. Try to draw it in there straighter. And then the equation of the other one. So again, we'll use point slope form for that. Y minus y1 equals m times x minus x1. We know the point that we're going to use is the center here, which is 2, negative 3. We just need to find our slope. Well, our slope is up 1 over 1, 2, 3, 4, 5. So my slope is 1/5 for the up and to the right one, and negative 1/5
for the up and to the left one. So my equation then is y plus 3 equals plus or minus 1/5 for my slope times x minus 2. And there's the equations of our asymptotes using point slope form. So that's kind of a quick, not quick, 15 minutes worth of introduction into hyperbolas. Best of luck. See you next time.